Hi, my name is Jason Sawala, and I'm from Hatfield Consultants. I'm pleased to be with you today to introduce you to GEO Analytics Canada. GEO Analytics Canada is a cloud-native open platform for big data geoscience that can be customized and deployed in your own cloud or HPC infrastructure. It allows users to analyze satellite Earth observation data in ways not possible using traditional desktop tools. The volume of satellite Earth observation data available continues to grow. In 2015, NASA's Earth Observation Archive was 15 petabytes. By 2019, that number had increased to 32 petabytes. And by 2025, it is expected by NASA to grow to 246 petabytes. With these huge amounts of available satellite Earth observation data now available, it's obviously impossible to analyze these data sets using the traditional approach of downloading the data and analyzing it using desktop tools. To showcase how we can overcome these challenges of analyzing huge amounts of satellite Earth observation data, Hatfield has created GEO Analytics Canada, a cloud-native analytics system that brings the user and their tools straight to the data, completely removing the need to download these massive data sets. GEO Analytics Canada is not the only satellite Earth observation data analytics platform out there. We've used many of these other platforms ourselves and have even worked with other companies to develop some of these other platforms. So what makes GEO Analytics Canada different, and why partner with us to help overcome your big geospatial data analytic problems? First of all, we can help you build and host your own satellite Earth observation data analytics platform. The GEO Analytics Canada platform is made to be implemented on your infrastructure. When using your own infrastructure, Hatfield's cloud computing and geospatial analytics experts are available to support your project. Secondly, it's an open system. We believe that platforms should not require all data and tools to be centralized in one place, such as what Google Earth Engine and other systems require. Thirdly, GEO Analytics Canada is cloud native. This means that it is built from the ground up using cloud computing technologies so it can fully support the power that comes from these modern technologies. GEO Analytics Canada is developer friendly. You can create your own algorithms and systems right on the platform and scale them dynamically and massively. It's desktop app friendly. Many of the same desktop apps you are used to using, such as QGIS and Snap, are available directly on the platform. It uses the latest user and machine-friendly Open Geospatial Consortium protocols, such as Stack, API features, and API processes. GEO Analytics Canada is infrastructure vendor agnostic, so we can work on a wide variety of cloud computing and HPC infrastructure providers. It supports the key tenets of open science: openness, transparency, scrutiny and traceability of results, access to large volumes of complex data, and the availability of community open tools. And finally, GEO Analytics Canada is designed specifically to support Canadian organizations and Canadian privacy laws. So, how does GEO Analytics Canada work? Let's give you a brief run-through. The GEO Analytics Canada platform has three overall parts: an infrastructure service that is shown at the bottom of this diagram, a suite of software services shown in the middle, and a suite of APIs used to interact with the system both internally and externally. For its computational power, GEO Analytics Canada uses Kubernetes, which is a system for automating deployment, scaling, and management of containerized applications. Most all cloud infrastructure vendors support Kubernetes, which allows us to be infrastructure vendor agnostic. For storage of all our EO and analysis-ready data, GEO Analytics Canada relies on object storage systems. Object storage systems provide built-in redundancy, can scale to exabytes of data, and have the lowest cost. Our object storage system currently hosts 20 years of Modis data, all our analysis-ready data, and provides direct access to the entire archives of Landsat and Sentinel-2. For users' personal data, we have implemented a NFS server, which allows users to have their own home directory with their own private data in it. On top of this scalable computational and storage system, we have built a number of integrated systems that users can access. All systems are available through the geoanalytics.ca website through our single sign-on authentication system. Once logged in, the system's landing page provides you with access to all system functions and documentation. To batch process satellite Earth observation data, we have implemented a system called Kubeflow, which actually is primarily designed to enable machine learning workflows, but we have repurposed the same systems and mechanisms used for machine learning to also ingest and batch process satellite Earth observation data. Using this system, we have been able to ingest and process 20 years of Modis data in a matter of hours, and have been able to process 100 Level 1 Sentinel-2 tiles using Sen2 Core in less than 40 minutes, wall to wall. Once satellite EO data has been ingested, it is made available in our EO browser system. The EO browser system, which is built upon the Spatiotemporal Asset Catalog, or STAC, standard, allows all ingested products to be browsed and searched for. For example, you can browse through the EVI2 products, or you can search the Landsat 8 products available in Eastern Canada. Ground truth data is important for all machine learning algorithms. We have made a simple system for ground truth data that allows shapefiles and other geospatial files to be uploaded and made available through an OGC API features API. On GEO Analytics Canada, we have implemented a Jupyter system. However, our Jupyter system isn't your standard Jupyter setup. Instead, it implements what is called a Pangeo environment, which adds functionality to Jupyter to allow Python code to be scaled dynamically and massively using the full power of the underlying infrastructure. To allow traditional desktop applications such as QGIS and Snap applications to be used directly on the platform, and to avoid downloading these data whenever possible, we have developed a system that allows Ubuntu-based desktops to be spun up on our Kubernetes infrastructure. These desktops have a dynamic amount of RAM and CPU available to them, and have direct access to all datasets hosted on the platform, therefore removing the need to download any data. So in conclusion, we would recommend that you should avoid getting bogged down with the desktop analytics tools that can't handle today's datasets, and instead transition to cloud-native analytics available through GEO Analytics Canada. Bring yourself and your users and your analytics to the data, not the other way around.